Come to the world of inferential statistics. And the first concept that we will learn in inferential statistics is what is hypothesis testing. Very simple. What is hypothesis? Hypothesis is nothing but assumption. And what is assumption testing or hypothesis testing? We are trying to do some scientific experiments. First, we collect the data, we clean the data, we do all the data transformations, we prepare the data, and then we apply some scientific method, or to be precise, we apply specific tests like Z test, T test, chi-score test, F test, ANOVA test, whichever is the right test. And then we find out whether we can conclusively say that this assumption is correct, or this in nutshell is hypothesis testing. For example, the most famous example that is quoted when we have to understand hypothesis testing is a tossing of coin. Tossing of coin. Say suppose I and you are playing a tossing a coin experiment. And every time you toss, you are getting a head. And we repeat these experiments. Then there will be a time when you will get frustrated and say that no, this coin is not fair. This usually happens, right? So it is at that stage we would say that the coin is not fair. But in statistics, we do it using experiments, we record the observations, and we have some specific numbers at which we say that this hypothesis has to be rejected. So let me explain you with this example. So the null hypothesis is the coin is fair. Okay. An alternate hypothesis is coin is not fair. So whenever we do hypothesis testing, we create a null hypothesis and then we create an alternate hypothesis. How do we create a null hypothesis? Always remember that null hypothesis is always the rosy picture. It assumes that everything is equal, everything is good, the world is utopian. For example, in this case, coin is fair. To give you another example, if I have to prove that female employees are being paid less as compared to male employees in terms of salaries, then my null hypothesis would be that the male and female salaries are not very different. Or to frame it positively, there is no difference between male and female salaries of male and female. Sorry, how to frame it is that there is no difference between income of male and female employees. So that is the utopian, that is the best possible scenario. Alternate is the negative of it, that the coin is not fair. Or in the salaries of male and female employees, the alternate would be the male and female salaries are different. So that is basically hypothesis, how we frame the null hypothesis, how we frame the alternate hypothesis. So in this coin tossing experiment, right, let us conduct some experiments. Say for example, first time when I play, 50% of the time I get heads and 50% of the time I get tails. Then I say that okay, the coin is fair. In the second experiment also, I toss the coin say 100 times, 500 times, how many number of times I am tossing it. In that situation, when I aggregate the results, 40% of the time I am getting head and 60% of the time I am getting tail. Then also I am okay. I say that yes, the coin is fair. In the third experiment, I toss the coin 100 times, 500 times, And then I aggregate the results and see that only 10% of the time I got a head and remaining times I got a tail. Then I'm starting to doubt. Okay, my doubt increases that whether the coin is biased or it is not fair. When I do the fourth experiment, I find that only 5% of the times I have got head and remaining I have got tail. This is the point in statistics. This is the point in statistics where we say that the coin is not fair. This thing, the coin is not fair. And this 5% can be different for different industries, types of experiments that you're doing, but usually it is 5%. So, what is 5%? 5% is nothing but this is called the level of significance. Or you can also represent this 5% as 0.05. When you represent this as a 0.05, it is called as p-value. And what is p-value? P-value is nothing but the probability of the null hypothesis being accepted. If we do that is 95, this 95% is called confidence interval. It tells that you have conducted a series of experiments over and over again, and with 95% confidence, we can say that the coin is not fair. So, that is all about hypothesis testing. Now, let us see which test to use when in the hypothesis testing. So, it really depends on the data type and the type of question we are solving. We decide which statistical test will be appropriate. Usually, the data can be numerical or categorical, right? Either we can have numbers or we can have categorical data, for example, male, female. This way, we can have categorical columns, or we can have data as this is categorical data, and then we can have numbers, right? We can have 50K, say, suppose this is salary, 60K, 100K. We can have categorical and numerical data. So, based on the data that we have for that problem, we will decide which test to use. First, let us see t-test. T-test is for numerical data. So, for example, if I have to prove that female employees earn more than male employees. Okay, this is my assumption. This is my hypothesis. So, first I will frame my null hypothesis and then I will frame my alternate hypothesis. So, null hypothesis, you remember, right? Null hypothesis is the best situation. So, most ideal situation. So, my null hypothesis is there is no difference between male and female salaries, and alternate hypothesis is that there is a difference. There is a difference. Now my data is numerical. What I will do, I will create one column for, or I will create one series of data for females salaries, and then I will have one set of salary data for males. And then I will apply the t-test. For example, you can see here I have one set of data for male employees and one set of data for female employees. And depending on the tool that you're using, you might use Excel, or you might use R, or you might use Python, or you can also use an online statistics testing tool where you feed in the data and you get the output in terms of p-value. And when you get p-value, it will also tell you that whether p is less than 0.05 or p is greater than 0.05. And if p is less than 0.05, then it tells that the results are significant and there is a difference between salaries of male and female employees. So that is about t-test. Simple t-test would be such kind of a test. One-tailed t-test would be where we are testing that female employees' salary is greater than male employee salaries. A paired t-test would mean that we are pairing the observations. So, for example, in COVID, we usually saw that after COVID, we saw that there was increase in employee engagement because most of the commute that employees had to do, was no longer there. They were more productive and hence their engagement increased. So, say suppose if I create a data set of employee A, employee B, employee C, and then I measure that what was their engagement before pre-COVID and what was their engagement post-COVID. And this will be some numerical value. So, this would be a paired t-test. Now, let us look at ANOVA test. Similar to t-test, we have ANOVA test. In ANOVA test also, we are comparing numerical values, but the only difference is that we have more than 2 categories across which we are comparing. So, here we had male salaries, female salaries, and here in ANOVA we have, say suppose we can take a different use case where we are comparing salaries for different countries. So, for example, the US, India, China, and then we are trying to compare that are the salaries different, very different in these 3 countries, or is the level of employee engagement different for all these 3 countries. So, we have more than 2 categories where we are trying to compare. So, this is nothing but ANOVA. So, t-test is for numerical and ANOVA is also for numerical. Now, let us look at chi-square test. Chi-square test is when we have categorical data for which we are trying to find any meaningful difference. So, for example, if I give you a question, are college hires better performers? I'm taking a very live example here. Are college hires better performers? So, what is the first data point? College hires. Whether this person is a college hire or not. So, I will have 2 flags, whether this is college, whether this is non-college. Similarly, better performer would mean best or top performer, not top performer. And then based on that, if there are 1000 people in the company, then I will create a frequency table here. Similarly, I will create a frequency table here. And based on this, I'm going to run a chi-square test. And you can run the chi-square test based on whichever favorite tool you are having. You can use Excel, you can use Python, R, or you can also use statistics app. And I will share the link of that statistics application where you can just plug in the data and you can get the p-value, whether the result is significant or not. Now let us look at z-test. So z-test is basically used to compare the two distributions. Here we assume that we have the population mean, standard deviation of the population, and to compare, say suppose within our company we want to compare, we just need to ensure that the sample size is greater than 30. Let me explain this with the help of example. We want to solve for a question that are we paying high, very high as compared to what the industry salary is. So for example, the average salary is 60K. For this job, for a particular job in the industry, the salary average is 60K. And I know that the plus minus standard deviation is 5,000. So we collect samples of 100 people in the company who are in this job, and then I'm able to find that, okay, in my company, the average is 62K. So in order to find that whether we are paying significantly different from what the industry average is, we can do a z-test. We are going to standardize using the z-test and then calculate the p-value. Again, you don't have to calculate a p-value. You just know that now we are comparing two distributions, the salaries of your employees in the company versus the salary of the entire industry. So now we are comparing two distributions, and when we are comparing two distributions like this, we can use the z-test. So that was all about choosing the right statistical test for the hypothesis testing. I know it seems like a lot, but believe me, nowadays you can easily ask the ChatGPT and Google that which test to use when you have such kind of a data, and you can get the answer for that. Not only that, it will also give you the code that how you can implement that test and also interpret the value, the p-value that you get. So I hope I was able to explain that to you. If you have any questions, please ask me in the comment section and I'll be happy to help you. Thank you. And with this, we end the series of a Statistics for Data Science series. I hope you learned something new. Thank you for watching.